For both methods, we're going to do both methods on this one. Let's first start by identifying the LCD. And what would the LCD be on this guy? Well, what do you have? You have this denominator, x minus 2. You have this denominator, x plus 1. You have another denominator, x. There's nothing in common, guys. So what's the LCD going to be? It's simply going to be all three of them together. X minus 2 times x plus 1 times x. That's the LCD. So bottom line is I'm going to have to multiply every single one of these by that LCD. So let me do that. Let me put a x minus 2. Let me put a x plus 1. And let me put an x. Let me do the same over here. X minus 2, x plus 1, and x. And we're also going to do that to this side down here. X minus 2, x plus 1. Since I ran out of space, let me put the x over here. Anyhow, what we're going to do now is, we're going to kind of ignore the bottom for a little while. So I'm just going to focus in on the top. And the x minus 2 up here cancels with that x minus 2. So once again, this guy cancels with this guy. And what's going to be left up on the top, you're going to have a, and let me rewrite this. This is what I have up on top. I have a 16, and I also have a times x. Where did I get that times x from? It's right here. This x is left over, so I'm going to put it right next to the 16. And at the very end, I'm going to put the x plus 1. Now, I do have the option of distributing that 16x, but I'm not going to do it. Anyhow, that's all we could do with the top one. We canceled out the LCD with the denominator, and we ended up with 16x times x plus 1. So, let's look at the bottom part now. And what cancels? The x minus 2, nothing cancels, but the x plus 1 cancels with the x plus 1. So you go ahead and put a line through that and a line through that. Now what's left over? Well, you have the original 4 that's left over. I'm going to bring that down. There's a 4 right there. And I also have this x that's left over. Let me bring that down. You have an x right there. And you also have the x minus 2 that's left over. X minus 2. Okay, now keep in mind that we do have a plus sign between all this. So let me put a plus sign between all that. We also make this fraction bar a little bit longer. And let's look at the second fraction in the denominator. So this x over here cancels with that x, nothing else. So let me actually go through and cancel this x with this x, make it disappear. What's left over? We have a 6 left over from here. And then we also have x minus 2 times x plus 1. So let me bring those down. X minus 2 times x plus 1. Okay. Now, of course, I could start distributing 4x times x and get a 4x squared, 4x times negative 2 and get a negative 8x, and then distribute 6 times x. But see, it's a lot of distribution, so I'm not going to do that. Actually, what I'm going to do right now is kind of, whoops, hold on a second. Let me first get rid of this so we can see everything. Okay, and now what I'm going to do is kind of use a trick. So if you look at the top, instead of distributing, I'm going to leave it like that. I'm going to leave it at 16x times that binomial. And on the bottom, I want to take a look at it like as if it were one group plus another group. It's kind of like factoring by grouping. I'm going to pull out what's in common in both groups. So on the bottom, I'm going to pull out the x minus 2. And what will I have left over? I'm going to use brackets to show what's left over. I will have a 4x left over, and I will also have a plus 6, but then again, the x plus 1 also comes down because this x plus 1 right here comes down right there. So we pulled out the x minus 2. Both of these guys came out, and you have a 4x and a 6 and also an x plus 1. Now, if I want to simplify this a little further, I'm going to rewrite it one more time. I have a x minus 2 bracket, and this is going to be 4x And this 6 times x gives me a plus 6x. And the 6 times 1 gives me another 6. And one final time, I'm going to combine the x with the x. So my final denominator will be x minus 2 bracket 10x plus 6. Okay? So this is what's on the bottom. And what do we have on top? We have a 16x times x plus 1. So this one is really ugly. I apologize. Let me rewrite what I have left. Up on top, I have a 16x times x plus 1. And on the bottom, I have x minus 2 left over. So I'm going to write that down, x minus 2. However, check this out. If I take a look at this bracket, I have a 10x plus 6. I'm actually going to pull out a 2 because both of them are even numbers. So if I pull out a 2, I'm going to have what left over? I'm going to have a 5x plus 3. Now, why would I want to pull out that 2 from both of these? Well, this 2 down here with the 16 up here cancels out, and you end up with the 8 left over up on top, which gives you your final answer. And the final answer is 8x, x plus 1, x minus 2, 5x minus 3. That's your final answer right there, in factored form, that is. So that might look a little confusing, because it is. It's a lot of work. What other options do we have? Well, I guess since all three denominators of the three fractions originally, you see how this one's an x minus 2 and this is an x plus 1 and that one's an x? There's nothing in common. So when there's nothing in common, like this is an x plus 1, if this were an x plus 1, go for it. Use the LCD shortcut, multiplying everything by the LCD. But if they're all totally different, like right here, you might as well go with the old method. It probably makes a little more sense. So let me compare this with the other method, okay? With the original method of simplifying the bottom. There's nothing to simplify on top, and then rewriting it as a division problem. Let me start over here. Here we go. So I'm going to tackle this one with the first method. Now, what's the first method? Is there anything you could do up here? And the answer is no. So we're just going to leave it like that. We're going to call that the top. Now, is there something to do down here? Yeah. You have addition of two fractions. So let's actually ignore the top because there's nothing to do on top, and let's add this fraction with this fraction by getting a common denominator. So when I say ignore the top, we could just block it out for right now. And the bottom, how are we going to add that? Well, obviously, we need common denominators, and the common denominator will be this denominator multiplied by this denominator. So that's going to be a x plus 1 times x. And let me put an x out in front better. X times x plus 1. X times x plus 1. Okay? So how do we change x plus 1 to become x plus 1 times x? Well, you obviously have to multiply the bottom and the top by x, and we end up with a 4x up here on the numerator. Now the question is, how do you change this x to become a x times x plus 1? Obviously, you're going to multiply both top and bottom by x plus 1. And of course, you're going to have to distribute 6 times x. That gives you 6x. And then 6 times 1, that gives you plus 6. So now that we have a common denominator and a common denominator, now we're able to add the top with the top, right? So my answer will have the common denominator x times x plus 1. And on top, you will have, what is 4x plus 6x? That's a total of 10x's. And what about the plus 6? Just bring it down. So you really have 10x plus 6 over x times x plus 1. And that's pretty much all you could do besides factoring out a 2 from the top. So we might as well do that, I guess. Let's factor out a 2 from the top. Whoa. if I do factor out a 2 from the top, it will be 2 and then 5x plus 3. And on the bottom, you'd still have the x times x plus 1. Okay, so down here, this is really the bottom of the whole thing. Now remember, the top, we ignored the top for a little while. So let me move this out of the way. But on top, we have 16 over x minus 2, and on the bottom, we have this. But instead of writing it on top and bottom, remember, that's a division problem. So let's write it side to side. Let's say this guy divided by this guy. And let's write it horizontally. So I'm going to rewrite it. 16 over x minus 2 divided by the bottom one, which is 2, 5x plus 3 over x plus 1. And now the trick is, I'm going to keep the first fraction. I'm going to rewrite it. It's 16 over x minus 2. That's a 6. Sorry. That's the ugliest 16 ever. Anyways, multiplied by, and let's flip this second fraction, right? Flip the second fraction. We'll change it to multiplication and flip the second fraction. So we're going to end up with x times x plus 1 on top, and on the bottom you have 2 times 5x plus 3. Okay, so now what do? We are going to simply multiply. Well, we can't cancel anything out except for the 2 with the 16. That's going to become an 8 up on top. So everything else we're just going to rewrite. So what do we have as a final answer? A final answer is, up on top we have an 8x, and then the x plus 1. And on the bottom, you have x minus 2 times 5x plus 3. And that would be your final answer there, because nothing cancels out. So I think that when all three denominators are different, like once again, this is x minus 2, x plus 1, x, they're all different. Might be a good idea to just simplify the top, simplify the bottom, and then rewrite it as a division problem. This guy divided by this guy. Change it to multiplication, flip the second fraction, and then just cancel things out and rewrite your answer. I think that's a little bit easier to understand when all of your denominators are different. However, if you have a shared denominator, like this guy right here, we already did this one on the other video, but if you have a shared denominator, see how you have an x minus 1 there and an x minus 1 there? Right there, it'd be convenient to multiply everything by your LCD, which would be 2x times x minus 1. I hope this makes sense.